Hello everyone, welcome to this training session on development of 1D models using MIKE11. In the previous session, we saw how to delineate a basin using ArcGIS. Now, using those results, we will develop a 1D model using MIKE11. So, let us begin. Create a folder named Tapi Mike. Open MIKE0 from Start menu. Click on New File button and this dialog box appears. We will begin the work from creating a river network file. So select MIKE11, then select River Network and click on OK. Map Projection and Working Area dialog box opens. Here we have to select the projection of the map and coordinates of the working area. So in projection, follow these steps and select UTM-43. Working area should be selected such that your basin is covered in the map. So I enter these values and click on OK. This is the map. Now the layers of river, sub-basins and stations have to be added on this map. Click on Layers menu and select the Add or Remove option. Layers dialog box opens. Click on this icon to add a new file. Now select the file type as shapefile and click here. Now select the shapefile of river from Tapi ArcGIS folder, which was created during delineation. Here, select the column containing the names of the river branches and click on OK. Similarly, add the shapefiles of subbasins and stations and click on OK. The files we added are not getting displayed here. That means they do not lie within the coordinates provided. So, click on Network menu and open Workspace Area and Map Projections. Enter these values of coordinates and click on OK. Now see, the layers we added are getting displayed, but we need to adjust the coordinates in such a way that the map contains only the edit layers. For example, open Workspace Area and Map Projections and enter these values. Now the map looks like this. Now adjust the value of these coordinates until the map looks like this. Now save this network file in Tapi Mike folder. Now open Network menu and select Generate Branches from Shapefile option. Select Generate Point and Branches. Select name of the column containing river names here and click on OK. Now open Network menu and select Auto Connect Branches option. Now click on Save. Now open View menu and select Tabular View. Double click on Network and then click on Points. Now for the first and last chainage of a river branch, change the chainage type to user defined and round off the chainage value to an integral value. This is done just for the ease of using the data. And this has to be done for the first and last chainage of all the branches. Now click on Branches. Round off the values in Downstream Chainage Connection column. Then click on Structures. If any structure has to be added, then it can be added from here. Now click on Runoff Groundwater Links. Select Rainfall Runoff Links. Here, name contains the name of subcatchment. Branch name is the name of the river branch contributing to that subcatchment. Upstream and downstream chainages are the chainage values of the points where that branch starts and where it ends in that particular subcatchment. If more than one river is present in a subcatchment, then corresponding to a particular branch, area contains the value of the percentage of subcatchment that contributes to that particular branch. So we prepare this table in an Excel sheet and then copy it here. Now open ArcGIS. Add the shape files of the basin here. Open the attribute table of subbasins and copy all the data. Paste it in Excel sheet. From this, we require only the subbasin name and corresponding area. Now, starting with subbasin Tesca. As is visible here, it contains only one branch, that is Tapi. As only one branch is present, so whole area of the subbasin will contribute to that branch only. Now, open network file in MIKE to get upstream and downstream changes of Tapi in subbasin Tesca. So, zoom in here, then double click on this point, and this is the change value. Similarly, enter the data for all other subbasins. Now let us see one more case when more than one branches are present in a subbasin. The subbasin Gopal Kheda contains two branches, Katapurna and Purna. So a percentage of area of Gopal Kheda will contribute to Katapurna and the remaining percentage will contribute to Purna. These percentages are decided by visualization only. So enter the values in the table like this. I have assumed that 30% of the area contributes to Katapurna and 70% contributes to Purna. Now enter the upstream and downstream changes of these branches for Gopal Kheda and complete this table for all other subbasins. After completing, copy the whole table and paste here in MIKE. Save this and close the file. The network file has been created. Now let us create cross-section file. Click on New File button, select MIKE11, then select MIKE11 cross-sections and click on OK. Save this file in Tapi Mike folder. Close it, then open it from here. Now we have to add the cross-section data of all the sites. So right click here and click on Insert Blank Cross-section. Provide the branch name and enter the same in Topo ID also. Enter the chainage value of the site whose cross-section data has to be added. In ID, provide the name of the site. Click on OK. Now click on Raw Data here. The data can either be entered here or you can copy and paste it from Excel sheet. Resistance value will be 1 as it is relative resistance. Datum value can also be provided on the right hand side. You can also choose the distribution type, that is whether the flow is distributed or whether it is a high or low flow zone. After completing, click on Update Markers button. Now for entering data for any other cross-section on the same branch, right click near its name and select Insert Cross-section in this Topo ID. And for entering cross-section data for a new branch, right click and select Insert Blank Cross-section. Enter the cross-section data for all the sites, save the changes and close the file. Now let us create boundary conditions file. Click on New File button, select MIKE11, then select Boundary Conditions and click on OK. Here for all the branches at 0 chainage, select the boundary description as open and give the boundary type as inflow. Then in the table below, change the TS type to constant and give the value as 0. Do this for all the branches. After that, add one more row. Here we have to give the boundary condition for last point of the model, that is point where the main river ends or meets the sea. So change the boundary type to water level. Enter the chainage value of the last point of the river Tapi. This can be taken from network file of the model. Change the TS type to constant and give the value of water level of that point. Now click on Save and save this file in Tapi Mike folder. Now let us create RR parameters file. Click on new file button, select MIKE11, then select RR parameters and click on OK. Here we have to enter the name and area of all the subbasins. So open ArcGIS and copy the attribute table of subbasins and paste it in an Excel sheet. Remove all other columns. Now click on Insert Catchment button and enter the details of all the subbasins one by one. Now click on Save and save this file in Tapi Mike folder. Now these are some NAM coefficients whose values are to be adjusted during calibration of the model. So this will be discussed later in the subsequent lectures. Now click on Time Series tab. We have to link the rainfall and evaporation time series of all the subbasins with them. So first, let us create evaporation time series. Click on New File button and select time series and click on OK. Select blank time series. Enter the title as evaporation and select the axis type as non-equidistant calendar axis. Now give the name of the column as Tapi basin. Select the type as evaporation and select TS type as step accumulated and click on OK. So this is the time series. Here you can either enter the data manually or copy from Excel sheet and paste here. Here I have taken a single value of evaporation for the whole basin. For better accuracy, you can provide the values sub-basin wise also. Now click on Save and save this file in Tapi Mike folder. Now let us create rainfall time series. Click on New File button and select time series and click on OK. Select blank time series. Enter the title as rainfall and select the axis type. You can select equidistant calendar axis while creating the time series if the data to be entered is equidistant. But do change it later to non-equidistant so that the model does not show any error in case of non-equidistant data. Now give the name of subbasin as name of column. Select the type as rainfall and select TS type as step accumulated. Enter the name of all the subbasins by clicking on Append button. Then click on OK. So this is the time series. Here also you can either enter the data manually or copy from Excel sheet and paste here. Please note that the evaporation and rainfall time series data shown here are just for reference and may differ from original data. You need to enter the actual values while creating the model. Now click on Save and save this file in Tapi Mike folder. Both the time series have been created. Now they have to be linked with the corresponding subbasins. So select the subbasin Tesca from below by clicking on the number beside it. Now for linking rainfall time series, click on browse icon here. Select rainfall time series from Tapi Mike folder. Then in bottom pane, in item, select Tesca and click on OK. For linking evaporation time series, click on the browse icon here. Select evaporation time series from Tapi Mike folder. Then in the bottom pane, in item, select Tapi basin and click on OK. Repeat this procedure for all the subbasins. Then click on Save and close this file. Now let us create HD parameters file. Click on New File button. Select MIKE11, then select HD parameters and click on OK. We will not make any changes in the default values shown in HD file. These values are changed if needed only during calibration. So click on Save and save this file in Tapi Mike folder and close it. Now let us create simulation file. Click on New File button, select MIKE11, then select Simulation and click on OK. Select Hydrodynamic and Rainfall Runoff checkboxes. Now click on Input tab. Here browse and select all the files which were just created. Then click on Simulation tab. Provide time step. Lower time step means better results and longer time taken by the model to run. So accordingly select a suitable time step. Now provide simulation start and end time. When the model is run for the first time, For previous year's data, select parameter file in initial conditions for both HD and RR. Then click on Results tab. Provide file name for HD and RR. Then click on Browse button and select the location. Then click on Start tab. Click on MIKE11 Classic button. Save the simulation file and the model will start running. If there is any error in the model, then here the message will be displayed: terminated due to error or completed with error, and the model will stop running in between. Now, as the model has completed running without any error, so the developed model is working properly. There is one more thing that has to be understood here. In initial conditions, we have selected parameter file option. Please keep in mind that this is selected only when the model is run for the first time using previous year's data. After that, when the model is run on continuous basis, then in initial conditions, we select hot start file option. Check on these boxes. In hot start file name, the result file that was created during previous run has to be given. So what happens is that whenever the model is run for a new period with hot start condition, then the corresponding results automatically get appended to the previously created result file. So you need not run the model for previous year data every time. Now let us see how to view the results. Open MIKE view from Start menu. Open the HD result file. Note that here the first and last time steps are same as the simulation period provided by us. Check that both the water level and discharge data are selected and then click on OK. This is the horizontal plan of the basin. Now to view the results, click on Plot tab and select time series. Firstly, let us view water level results. So select water level and click on List. This contains the list of various points on rivers along with their chain ages. So select any point whose graph you want to see and click on Draw Graph. So this is the graph of water level of this point. Now to view discharge, click on Plot tab and select time series. Select discharge and click on List. Select any point and click on Draw Graph button. So this is the plot of discharge. Now one more thing that can be done is comparing the result of water level or discharge obtained using MIKE11 with those measured in field. So for that, first you need to form the water level or discharge time series of the data measured in field. Then right click here and select external TS. Click on Load DFS 0. From here, the time series can be selected and then corresponding graph will be plotted here along with this one. And you can easily visualize both the graphs together. So this was all that was needed to develop a 1D model using MIKE and viewing the results. Hope you understood it well. All the best.